Yes. So coming to the first project, we'll see this diabetes detection, like diabetes classification. So prior to that, like whatever the projects I want to explain you here, in all the projects, I'll take help of Kaggle. Like I'll explain you how to take a data set from Kaggle. So for that, initially you should have a Kaggle account first. Okay. So to have an account, what you can do is simply you can go to Kaggle. Yes, directly it is taking me into my account in the Kaggle. Okay. I, I hope it is taking. We'll see. No, it's not. So I'm clicking on sign in. If you are doing it first time now, like you can click on register. So I'm signing in with Google as I already have an account in it. Okay, and it's asking all my accounts, which email ID I have to choose. I'm choosing my personal one. Yeah, and you can see like what are the different things I worked here. So now after coming to the Kaggle, so initially what you can do is you can register for, in a Kaggle if you don't have an account. Once you register now, it will ask you with the email ID or Google account if you want to register. So you can register with any one of these two, like whatever you comfortable. After that, like you can set up a profile photo or anything, like that's your personal thing. And after that, what you can do is you can come to settings. After setting up an account, by default, here you'll get a duck symbol. You can click on that duck symbol so that you can see the settings here. If you click on settings, in the settings, you'll be having this API section. In this API section, you can see create new API token, new token like that. You'll see an option. You have to generate this thing for one time only. So the purpose of this API token is with this API token, any number of times you can download the data set. Okay. At any number of times, you can like not downloading data set, you can integrate Google Colab with the Kaggle at any time. Okay. That is the purpose of this thing. Now we'll go step by step. As it is a very traditional project and it's a very easy project, and here the lot of steps are involved. Okay. So initially, if you want to upload any file from local system into this Google Colab, you have to run this command. So if you want to run the complete code, you'll be having option. In a runtime, you can go to runtime and you can click on run all. And remember one more thing. If you are working on a huge project or bigger project, you can check runtime. So if you go to runtime, so at the bottom you can see change runtime type. So by default it will be CPU. CPU means it will be run on your local computer. So it will be bit slower. So you can keep it to T4 GPU or TPU V2. It means it will run on Google processing unit, like the soft like a space which was provided by Google. So if you work upon any deep learning project or bigger projects, at that time it will be helpful to you. So the execution will be completed bit quickly compared to CPU. Okay, so that's a cloud GPU. You'll get it. Now I am running the first command. So the purpose of this command is, so whatever the kaggle.json file you download, initially we have to upload that file. So as it will connect with the Google Cloud first, it is connecting. So I'm choosing file. So I'm checking for, yeah, I'll go to downloads. I'll check with the Kaggle name if I find any. Mm, think Kaggle.json is not available in this. Okay. So downloads. Okay. It's not there. Now what I'll do is I'll go to Kaggle. Here we'll be having create new API token, right? So generating new token will expire the previous key. Yes, continue. As I downloaded this, now I'll go to the code and here I'll try to upload that file. So you can see now this file got downloaded. So now I'm uploading this file. So it's one time process only. You can use same file again and again and again. Okay. So let's suppose if you logged in another system, there these credentials might not be available. At that time, you can download another file. Okay, now I uploaded. Here I can see my username and my secret key. It is like a password. With these credentials, I can integrate Kaggle with Google Colab. Now, next what we have to do is we have to set up a path for Kaggle. So as these are the basic Linux commands, you can use these standard commands to set up this completely. Okay. Then next we have to download the dataset. How to download the dataset from Kaggle then? To do that, what you can do is go to Kaggle and here search for the dataset. Diabetes, I'm searching with the diabetes. And here I am clicking on datasets. So I need a dataset only. So now what I am doing is after choosing datasets, I'll choose which dataset I have to take up. Okay. So now, yeah, PMI Indians dataset. It's a very famous dataset coming to this problem. So which is available in UCI machine learning repository. I'm clicking on this. So if you want to read description regarding this dataset, so you can read the context here. What is this data set about, and how each and every feature will be, how it will contribute, everything you can read it here. If you want to take this data set into the Google Column, what you can do is you can click on these three dots and you can click on copy API commands. So once you click on copy API commands, after clicking on these three dots while going into dataset page, you can come to the code block and here you can add that thing. So this is the API command for the data set which we are taking. Now, in front of this, what we have to do is we have to add exclamation mark. Here, we have to add exclamation mark. Like this, we have to take a data set. But in this example, I took in another data set, the same data set which was uploaded by other user. Okay, I'll show you. After running this, we'll get exact URL for this data set. I'll show you there. Now I'm running this command. You can see the dataset link we got. Now I'm clicking on this link so that it will take exact dataset file. So we took the dataset from this person. He uploaded same dataset, like it is the same dataset only. So from this we are taking the dataset. No description available. So but data is available here. So 23.87 KB data. We can download the dataset locally here and we can upload it to Google Colab locally. That's the one approach. If you're not comfortable to use Kaggle, you can download the dataset from here, from google.colab by running that command, however we did traditionally previously. Like that, you can upload the dataset there and you can work upon this. So like this, I copied this dataset. Copy AP command. After doing this, I kept this thing in the code block. So how to do that? So we have to copy it and in front of this, we have to add exclamation mark. The meaning of exclamation mark is we are downloading something. If you look at this now, both the lines will be as is. Okay. In this way, like we have to download the data set in the notebook. Once you download the data set now in the local, you'll be having the data set. So you can see the data set in the form of zip file. So if it is in the form of zip file now, we have to unzip this data set. To unzip the data set, we'll be having this command. Unzip this folder name. Like directly, while going to here, we can copy path. We can copy the path and we can paste it here after exclamation mark unzip space that path. Once you keep this now, this datashet will be unzipped. And if you refresh this, here the CSV file will becomes. So data diabetes.csv file will be available now. Now, as you know, the importing essential libraries, NumPy, Pandas for analytics, and Matplotlib and Seaborn for graphical visualization. Operating system is a module which is used to view like folders and like files where it is available and etc. So now, initially, like to read the data, we'll take the help of Pandas module. So by taking help of Pandas module, so as we are having data in the form of CSV file, we are reading the data present in the CSV file. This is the CSV file name. Okay. So now I'm keeping it in a comments. Like data set is the data set that columns is attribute which is used to see the column names. So these are the column names which are available in this data set. Now, next what I'll do is we have to analyze the data furthermore. So the first thing is data set dot head command. So the purpose of this head command is it will give you top 5 rows information. So in this, like you can see the data set behavior. So the number of pregnancies to the person, specific person who is like whose data is available in the data set, glucose level, their BP, their skin thickness, their insulin level, their body mass index, diabetes predictive function, and that person's age and outcome. So here the outcome is nothing but whether the person have diabetes or not based on these features. So in this data set, outcome is nothing but whether the person have diabetes or not. Remaining all are the inputs. These all are the inputs. If you look at this data now, we'll be having complete data in the numerical fashion. We're not having any string data. It means we need not to perform data cleaning much efficiently. Like converting string values into numerical values, that techniques we need not to apply. Similarly, if you look at the tail also, you'll get the last 5 rows. Okay. So the next what I am doing is now I want to know the number of rows and columns available in a data set. So for that, we'll be having data set dot shape attribute. Shape is an attribute which will give you the number of rows and columns available in the data set. So I'm printing it much pretty in a much pretty fashion. You can see this after running this, you'll see. So totally in the data set, we'll be having 768 patients records, and each and every record have 9 samples, like 9 features. Means like pregnancy, glucose, these kind of features are 9. Now the next describe is a method which will give you a statistical behavior of the data. So if you look at this now, like it will give you the statistical behavior. So coming to each and every column. So you can see the first attribute corresponding to count means number of values present in each and every column. Mean means average of each and every column value. So coming to the first value that is corresponding to pregnancies in India, like whatever the data set they have taken. So on that data set, on an average, the number of pregnancies that women faced is closer to 4, and average glucose level in the data set is 120. Average BP is 70. Skin thickness average is 20.5. Insulin level is this one on an average. And finally, you can see outcome 34 percentage. 0.34 means 34 percentage. It means 34 percentage of people have diabetes in the project, like in this data set. Remaining 66 percentage is the people who are not suffered with the diabetes. Like this, you can understand the statistical behavior of the data, like standard deviation, how each and every value will be deviate from mean. Okay, let's suppose average is 3.8. The maximum value or maximum number of pregnancies is 3.8 plus 3. 4 plus 3 7. Minimum pregnancies are 3 minus 3 0. Like that, we can understand max and min values as well. That is the meaning of standard deviation. Okay, like this, you'll get 8 statistical properties whenever you apply describe method. Okay, now once again, like what I am doing is I have to understand how many samples are related to non-diabetic patients and how many samples related to diabetes patients. To see that exact count, I am applying group by on outcome column. So in the data set, if you look at, we'll be having outcome column. On that column, I am applying group by function. After applying group by means it will categorize the data points. So group by is the function which is used to categorize the data. Let's suppose if you have two categories, it will give two categories count. Like here I applied size, that's why it is giving like that. Otherwise, it will categorize the data. Okay, so coming to this group by function, I am taking outcome column. In this outcome column, we'll be having two categories and I'm checking size of each and every category. So coming to the 0 category, we'll be having 500 samples. Coming to category 1, we'll be having 268 samples. If you have more than 2 categories also, you can apply group by function. Okay. So now I have to divide the data in the form of input and output. So coming to the output. So outcome column is my output, and except outcome column, the remaining complete data is our input. So for that purpose, what I am saying is from the data set, we are dropping outcome column. So here I'm saying axis equals to 1. The meaning of this thing is we are skipping the column. Means we are considering the column. So by default, axis will be 0. It means row will be removed. So here we are specifying column name, outcome column, axis equals to 1. It means we are dropping outcome column. Okay. Now I'm running this portion. So now we divided the data in the form of input and output. Now, if you look at the data set here, I don't run complete data set. I'll keep x.head. Now, if you run this, you will see the data set. If you look at this data set now you won't have outcome column in this. Okay. Now you don't have outcome column. Okay. Now it is our input. So for further analysis, what I am doing is, so in this data set, if you look at the data set now, here purely NaN values, not available numbers. Some data samples are missing. Those are kept with a 0. 0 means our NumPy will understand like there is a value 0. 0 means some value, it will understand like that. So for that purpose, what I am doing is I am checking in each and every column how many missing values are there. We have to check that. So to check that, what I am doing is by going into the data set, I am taking each and every column. Okay. And I am checking this condition equals to 0. Means if that specific value is 0, shape of 0 means I am taking the length. Okay. Like that, I am applying this function on all the columns. Shape means like as it is a one-dimensional data, it will give you size. In this case, shape means as it is a single attribute, it will give you a size, means a number of rows and number of columns. As coming to the pregnancies column, it is a single column. Okay, it will be having unique count of values with the zeros. Similarly, like for all the rows, we are doing that one. Okay, so finally, we'll get all the missing values corresponding to each and every column. Remember, it's a very traditional project. Okay, so coming to the another project, I'll explain you in a different way. Okay, so now this is the missing values count corresponding to each and column. Coming to the BP column, we'll be having 35 missing values. Coming to the skin thickness, we'll be having more and more missing values. Coming to the insulin, we'll be having 374 missing values. For all these missing values, by noting down all the missing values here in an order, I am plotting the graph for missing values for each and every category. Okay. As we kept the name like 2, 4, 6, 8, 10, right? In this, what you can do is you can keep the names. You can keep BP, glucose, skin thickness, BMI, insulin, like that you can keep. And in the graph, like you'll be having in this bar now, like you'll be having different attributes. You can keep like some attribute to rotate or something. Okay, alignment like 90 degrees or something, so that those things will be come up on that specific angle. Okay, like this, like roughly I represented the data here, missing value samples. Now we have to handle this missing values. As I told you, we'll be having different techniques. So to handle the missing values, in this example, what I am doing is I am taking help of statistics module. By taking help of statistics module, I am taking median function and I have to apply on the complete column. After applying this median function, I'll get a median of each and every column. So I'm taking median of each and every columns. So we'll be get a median value. After getting the median value from the data set, what we can do is like we can replace all the missing values wherever 0 is available. There we can keep those values. That's what I'm doing in this step. Okay, I'm keeping all the values with I'm replacing all the values with these values. You can see how we are doing means simple assignment we are doing. Data set of blood pressure column, data set of blood pressure replace function we are using. In the replace function, wherever 0 is there, there we are keeping value 72. Okay. Similarly, like coming to all the columns, we did same thing. It means wherever the missing values are there, they will be replaced with the average values. Now, if you look at the data, the average and everything will be improved. Okay. And if you check the missing values also, there won't be missing values. Now we are plotting the out like a graph for each and every category. Visualization we are doing. So initially we are plotting the graph for pregnancies. So the number of pregnancies which we are having in a data set. So 0 to 2 pregnancies will be having closer to 250 people, and around in between 2 to 3 pregnancies will be having closer to 180 people, and and 4 to 5 pregnancies mostly in the range of 1 to 120 people, 100 to 120 people are have given birth to 4 to 5 people, and more than 5 people you can see like 5 to 7.5 means 5 to 7 range 50 people are there. Like that we are representing the information regarding pregnancies corresponding to our data set. Similarly, for the glucose level, what could be the average glucose level of the person? So from the top graph, what we can understand is, so most of the people present in the data set had 0 to 3 pregnancies. Okay. And coming to the next information, coming to the glucose graph, what we can understood is, so most of the people's glucose level is in the range of 90 to 120. Wherever the peak is there, that would be the maximum value. Like that, we can understand. Similarly, BP level, what would be the maximum people's BP range? You can see most of the people blood pressure will be in the range of 70 to 80. Like that we can understand for all the features, like graphically we can visualize the data like this. Coming to the BMI, what would be the average value? The BMI is 30 to 40. Okay, that's not yeah. The next will be having insulin level. The average people insulin level will be 0 to 50. Most of the people's insulin level will be 0 to 50. Coming to the age group, here we can understand what could be the age group of the people which we consider in this project. So the most of the people whoever available in the data set are in the age group in the range of 23 to 30. Okay, like that we can understand. Now if you look at the data, we'll be having all the values not in a same scale. If you see, if you apply data set dot head function here, once again, so if you apply data set dot head function, all the features are not in a same scale. You can see glucose level in the values like in the hundreds, and pregnancies in the ones, one digit, insulin three digit, like that we can see. Now we have to scale all the values in the same scale. As you know, we'll be having several techniques. On that here I'm using min-max scalar. And by taking help of this min-max scalar, like a feature range 0 to 1, like I want to convert all the features in the range of 0 to 1 only. Okay. And the next I am specifying all the attributes and I'm applying this min-max scalar from sklearn. SC dot, like SC means min-max scalar. Okay, standard scalar I'm saying. I'm applying fit transform method and I'm applying all these dataset attributes. So now all the features will be converted in the range of 0 to 1. You can see all the values will be compressed in the range of 0 to 1. Now we'll be having correlation function. The purpose of correlation function is to see the dependency of each and every feature. It means how one feature impacting other features. To understand that, we'll be having correlation plot. So you can see by taking help of heat map and seaborne, I plotted this graph. So this graph contributes, or this graph will says like how one feature is impacting other feature. Okay. So if the value is closer to 1, means 100% correlation, means directly proportional relationship. If it is closer to 100 means it is directly proportional relationship. If it is closer to -1 means indirectly proportional relationship. In the x-axis you can see all the features, on the y-axis also you can see all the features. So if we consider last sample, age and number of pregnancies, you can see 0.54. It means 50 per percentage of dependency. It means if the person's age is high, they might have more pregnancies. Like that, you can understand this behavior. Okay, as time is running out, I'll go a bit quickly from here. Okay, that is about correlation part. Then next, we have to split the data set into two parts, training and test set. As you know this step, I'm applying this step. Okay. After splitting the data set, now I'm going to apply, as by looking at the data set, we'll get to know that this is a classification project. We'll be having output in the form of yes or no. So that's why, like, whatever the classification algorithms we can apply, I am importing all the algorithm from sklearn. Naive Bayes algorithm, logistic regression algorithm, k-nearest neighbors algorithm, support vector classifier, decision tree classifier, random forest, ADA boost, gradient boosting, bagging classifier. Like whatever the classification algorithms we have, I imported all the algorithms. Now I am whenever you import the algorithms, next step is we have to import the object. Like we have to create an object corresponding to each and every algorithm class. I am doing that step now. So after creating all the objects, now we have to train all the algorithms. Now here I am training all the algorithms. So to train the model, we have to consider training data, and in each and every algorithm, we have to take help of fit method only. After that, I am applying predict method to check each and every algorithm performance on a test data. Okay. As you know, these steps individually you did for each and every algorithm now. So now I'm combining all the algorithms here. Now to check the model performance, I'm taking all the evaluation metrics. Those are confusion metrics, classification report, and accuracy score. Okay. The next, I am plotting all the confusion metrics. So I checked all the classification metrics here. Now I'll plot all those confusion metrics with the different color notations for each and every algorithm. You can see how beautifully this is. Like you can see each and every model's performance here from starting onwards. You can see the first, it is the behavior of logistic regression, how accurately it performed. Yes and no case. Similarly, for all the algorithms, I plotted a graph here. Similarly, we checked the model performance for each and every algorithm. So logistic regression score, like as you know, as we checked here in this data set, like 35% of samples corresponding to category S and remaining 65% samples are corresponding to category no. So on such cases, we can't consider accuracy as a good metrics. That's why I consider precision or F1 score in this example. This is the F1 score corresponding to each and every algorithm. Now I'm plotting like a, so I'm fine tuning the algorithms here. If you want to do, you can do it. The fine tuning thing. If you want, you can do it. By fine tuning, we can increase the model performance or model accuracy. And finally, I'm plotting the graph for all the accuracies. You can see this is the accuracies graph. Like this, you can understand. Like this, you can process further, and you can conclude which algorithm is best for your problem. And similarly, like what I am doing is, if I give any new data sample, if I give any new observation, how our model will perform. So for that, like I am applying this best CLF dot predict method. With this, I'm passing the data of this thing: pregnancies, glucose, BP, skin thickness, insulin, and all these features I'm giving in the scaled pattern. But it is not a proper approach. We have to give in this way. So for that, initially we have to transform the data. So number of pregnancies will be 5, and the glucose level is 148, and the insulin level is 72, BMI is 35. Like that, we can give all the parameters and we can check what could be the category of this person. Okay. In this way, if we give, it is giving output like 1. Means if the user have